Hey guys, in this video we're going to be talking about reflections for different kinds of graphs. So let's say we had a graph that looked like this. So let's take the quadratic function. So we have point here. So 1 squared is 1, negative 1 squared is 1, 2 squared is 4, 1, 2, 3, 4. And yeah, something like this. So reflection is, think of looking in the mirror. You see a reflection of yourself. So think of this as the mirror. So think of the x-axis as a mirror. So when you're looking in the mirror, you see exactly yourself. So the reflection through the x-axis, think of this as the mirror. X-axis, or your mirror, causes the reflection. So point here. So you're going exactly one up. You're going to go 1 down here. And then 1, 2, 3, 4. So you're going the same distance on this side, the same distance on this side. So you're kind of building this reflection. So this mirror image through the x-axis. So that's a quick introduction to what reflections are. So how do you know if it's going to be folding this way, if the mirror is the x-axis or the y-axis? So how do you know what side the mirror is on? So changes on outside is a change vertically. In other words, the mirror, x-axis equals mirror. X-axis is the mirror. So important points, changes on outside, we have x-axis, that's the mirror. Now, for the y-axis, so changes, let's use a different color, changes on inside, on the inside, is a change horizontally, is a change horizontally. So when you think about it, for this example right here, we flipped it from up, facing this way, to down, facing the arrows facing up, to the arrows facing down. So that's a change vertically. And we use the x-axis. So, but if we wanted to use a change, if we had a change on the inside, it would be the y-axis. That is the mirror. So y-axis equals mirror. Okay. So y-axis is mirror. So that's some key points to remember. So let's look at a few examples. So let's say we had the equation, the function y equals negative absolute value of x. And let's look at y equals absolute value of negative x. So when we have these two functions, all we're going to do is just go back to our notes. Is the negative, so when looking at reflections, we're looking at the negative sign, observing the negative. So this refers to observing the negative. So coming down here, you see that the x is outside. It's not with the x. In this case, it is with the x. So whenever you use parentheses or absolute values or quadratic, so quick example, this is outside, this is inside with the x. So going back to this example, here we see that it's outside. It's not with the x. So this is going to be a change that is vertical over the x-axis. So we're going to start by drawing our absolute value function. 1, 2, 3. So we know it's going to be like this. And this way. It's not perfect, but we see it. And we know that it's over the x-axis, right? So all we're going to do is just draw the same graph on the other side. So make sure that you're following the points. So this should be right here. So you're going 1 down, so right here, 2 down, 3 up, 3 down. So you just want to be cognizant about that. Make sure you're having the exact same thing because this is a mirror. Okay. We can extend that a little. Okay. So, and then make sure if this is a quiz or test and it doesn't ask you to leave it, make sure you're erasing the blue graph. This is your final answer. Now for this function on the right, the negative is with the x. So we're going to just draw our graph. And this one's pretty easy. So this one says changes on inside. So we have a change on the inside. It occurs over the y-axis. So this is the mirror. So 1, 2, 3. 1, 2, 3. Okay. So all we're going to do is whatever's on this side of the graph, so whatever's on this side gets reflected onto this side. But recognize that the absolute value function, it's even. So that means that you can fold it in half over the y-axis. So you can fold this graph in half this way, and this side would line perfectly on top of this side. So this function is the same. So equals, so this is practically the same thing. So this is your final answer. Let's look at another example. And let's say we had, right, this is a good one. So y equals square root of negative x. So all you're going to do is draw your graph. If you already have one, that's okay. All right, so we know that the square root function goes like this. So draw your parent function first. 1. So root 1 is 1. Root 4, 1, 2, 3, 4 is 2. So it goes this way. But remember, we said that changes on the inside were, that meant that the mirror was the y-axis. So we're going to have to reflect this way. So all we're going to do is count how many from the x. So here we have 1 comma 1. So that's going to be on this side. So the point is going to be right here. Here we have 4 comma 2. So we're going to have negative 4 comma 2. So 1, 2, 3, 4. So same distance here and same distance from here to here. Okay, and then all you're going to do is draw your line. It's not perfect, but you can see that this is a reflection on the y-axis. So that's basically what reflections are. Just make sure you're observing where the negative is. If it's on the outside, you're going to have a change that is vertical over the x-axis. And if you have the negative on the inside, you're going to have a change that is horizontal over the y-axis.